Okay, lesson 2/6. Find the probability of rolling a number greater than 2 on a die. There are 6 possible outcomes. 4 of the outcomes are favorable. That is, 4 of the 6 outcomes are numbers greater than 2. So your sample space is 1, 2, 3, 4, 5, and 6. So 6 possible outcomes goes on the bottom of the fraction, right here. And then it wants numbers greater than 2. So 3, 4, 5, and 6. 4 numbers are greater than 2, so the number 4 goes on the top of the fraction. So the probability of rolling a number greater than 2 is 4 over 6, or you can reduce it to 2 over 3. A class contains 6 students with black hair, 8 with brown hair, 4 with blonde hair, and 2 with red hair. Find the probability of a black student with black hair. There are 6 students with black hair and 20 total. You add all of the students, 6 plus 8 plus 4 plus 2. So there are 6 students with black hair, 20 total students, so the number of favorable outcomes, 6, number of possible outcomes, 20. So the probability is 6 over 20, reduced down to 3 over 10, or 0.3. So the probability of selecting a student with black hair is 3 over 10, 0.3, or 30%. Remember, 3 over 10 would be 30%. A class contains 6 students with black hair, 8 with brown hair, 4 with blonde hair, and 2 with red hair. Find the probability of red or brown. So there are 2 students with red hair and 8 students with brown hair. So 2 plus 8 is 10. There are 10 students with red or brown hair. There are 20 total students. So the probability of a student having either red or brown hair is 10 over 20, 1 over 2, or 0.5, 50%. The probability of selecting a student with red or brown hair is 50%. A class contains 6 students with black hair, 8 with brown hair, 4 with blonde hair, and 2 with red hair. Find the probability of the student not being blonde. So you include the 6 students with black hair, the 8 students with brown hair, and the 2 students with red hair, for a total of 16. 16 students do not have blonde hair. So the probability is 16 over the total, 20. 4 over 5, or 80%. So the probability of selecting a student who does not have blonde hair is 4 over 5, or 80%. Find the probability of rolling a number less than 3 on a die. Well, how many possible outcomes are there? On a dice, there are 6 possible outcomes. And then find the probability of rolling a number less than 3. So that is 1 and 2. So there are 2 favorable outcomes out of 6 possible outcomes. So the answer is 1 over 3, or 33%. The probability of rolling a number less than 3 on a die is 1 over 3, or 33%. A gumball machine contains 40 red gumballs, 30 green gumballs, 50 yellow gumballs, and 40 blue gumballs. Find the probability of picking a red gumball. There are 40 red gumballs, and there are 40 plus 30 plus 50 plus 40 total gumballs. That is 40 plus 30 is 70, plus 50 is 120, plus 40 is 160. And there are 40 red gumballs. So the probability of picking a red gumball is 40 over 160, or 1 over 4, 25%. A gumball machine contains 40 red gumballs, 30 green gumballs, 50 yellow gumballs, 40 blue gumballs. Find the probability of green or yellow. Well, there are 50 yellow and 30 green gumballs. That's 80 out of total 160. So the probability is 80 over 160, which reduces to 1 over 2, or 50%. A gumball machine contains 40 red gumballs, 30 green gumballs, 50 yellow gumballs, and 40 blue gumballs. Find the probability of it not being a blue gumball. Well, there's 160 total, and there are 40 red, 30 green, and 50 yellow gumballs. So you add that together, that gives you 120 out of 160. The probability of picking a gumball that is not blue is 120 out of 160, which reduces to 3/4, or 75%. Find the odds of rolling a number greater than 2. Well, there are 6 possible outcomes, 4 are successes and 2 are failures. So the probability of to find the odds of rolling a number. There are 4 numbers greater than 2, 2 numbers less than 2. So 4/2, or 2/1. The odds of rolling a number greater than 2 are 2/1, or 2:1. Find the odds of rolling a number less than 4. Well, there are 3 numbers less than 4. There are 3 numbers greater than 4. So you would have 3/3, or 1:1. 1/1, or 1:1. The odds would be 1:1. You're equally as likely to roll either less than 4 or greater than 4. A card is selected at random from a standard deck of 52 cards. What are the odds against selecting a 2 or 3? There are 4 2s and 4 3s in the deck of cards, and there are 52, -4, -4, or 44 cards that are not a 2 or 3. The odds against a 2 or 3 are 44 to 8. There are 44 ways not to pick a 2 or 3, and there are 8 ways to pick a 2 or 3. So the odds against selecting a 2 or 3 are reduce 44 to 8 down, and it is 11 to 2. A card is selected at random from a standard deck of cards. What are the odds against selecting a 5, a 6, or a 7? Well, we know that there are 4 5s, 4 6s, and 4 7s. So the number 12 goes on the bottom. There are 52 cards total, minus the 12 for 5, 6, and 7. There are 4 of each. That gives you 40 cards that would fit that criteria. 40 cards are not a 5, not a 6, not a 7. 40/12 reduces down to 10/3. So the odds of selecting a card that are not a 5 or 6 or 7 are 10 to 3. Melvin is waiting to board a flight to Washington, D.C. According to the airline, the flight he's waiting for is on time 80% of the time it flies. What are the odds that the plane will be on time? Well, the probability that the plane will be on time is 80%, so the probability it will not be on time is 20%. So the odds of the plane being on time are 80 to 20, or you can reduce that down to 4:1. The odds that the plane will be on time is 4:1. 80% that it will be on time, 20% that it will not be on time. 80 to 20. If the probability that it will snow this weekend is 70%, what are the odds that it will snow? Well, the probability that it will snow is 70. The probability that it will not snow then would be 30. It has to equal 100. So we know that the the odds that it will snow is 70 to 30. Reduce that down, 7 to 3. 7 to 3 are the odds that it will snow. 7:3 or 7/3. End of lesson 2-6. Yeah.
That was already done.
Just pause that. Why are you going to the immigration office?
Cool.
Find plus or minus root 16/9. Plus or minus root 16/9 represents the positive and negative square roots of 16/9. So 16/9 equals 4/3. The square root of 16 is 4. The square root of 9 is 3 squared. And 16/9 equals negative 4/3 squared. We have both the positive and the negative. Another way to look at this would be plus or minus root 16/9. That's how we can also do this. Whenever you have this, the square root applies to both. So 16 over 9 equals 4 over 3 squared, and negative 4 over 3 squared, because we have both positive and negative. So the answer would be plus or minus 4 over 3. Positive negative of 16 over 9 equals plus or minus of 4 over 3. Find the root of 0.0144. So 0.0144 represents the positive square root of 0.0144. 0.0144 equals 0.12 squared. So 0.0144 is 0.12. Find each square root. Root 64 over 25. Well, we have the root of 64, which is 8, and the root of 25, which is 5. 8 over 5. Root 0.36, 0.6. 0.6 squared is 0.36. Name the sets or sets of numbers to which root 17 belongs. Because root 17 is 4.123, so on, which is neither a repeating nor a terminating decimal, this number is irrational. If it is neither a repeating or terminating decimal, it is an irrational number. 4.1231056 continues on into infinity, and therefore is irrational. Name the sets or sets of numbers to which 1 over 6 belongs. Because 1 and 6 are integers, and 1 divided by 6 is 0.1666, which is a repeating decimal, you might see a line over that last 6, meaning that it continues on as a 6. The number is a rational number. Repeating or terminating decimals are rational numbers. So we know this is a rational number. Name the set or sets of numbers to which root 169 belongs. Well, root 169 is 13. This number is a natural number, a whole number, an integer, and a rational number. It is them all. It is a normal number. Root 169 is 13. Name the set or sets of numbers to which negative 327 belongs. This number is an integer and a rational number, but because it's negative, it is neither a whole or a natural number. Name the sets or sets of numbers to which each real number belongs. 7 over 9, rational, because 7 divided by 9 is 0.7. Continues on, it's rational. Root 36 is 6, natural, whole, integers, and rationals. It's a normal positive digit. Root 45 is 6.708, ellipsis. It is irrational. It neither terminates nor repeats. And negative 56 divided by 7 is negative 8. Negative whole numbers are integers and rational numbers. Now, graph. Y is less than or equal to 8. If it is equal to, we shade in the circle at the 8, and then we draw a line to the left, indicating that all numbers to the left of 8 are included in the graph. The dot at 8 indicates that 8 is included in the graph as well. Graph each solution set. X is greater than or equal to 6. If we see this equal then, this line underneath, we shade in the dot, and the arrow is pointing to the right. Greater than, we draw the arrow to the right, meaning that we are referring to all numbers greater than or equal to 6. X is less than negative 3. There is no equal to, there's no line underneath, so the circle is open, it is not shaded in, and we draw the line to the left. The arrow is pointing to the left, it means less than, so you draw the arrow to the left of negative 3 with the open circle. Replace the dot with greater than, less than, or equal to make the sentence true. 14 root 196. Well, the root of 196 is 14. 14 squared equals 196. So we know that 14 equals 196. They are the same. Root 196 is 14. Replace the dot with a less than, greater than, or equal to make the sentence true. Root 48 and 6.9. Root 48 is 6.928. 6.9 with the repeating decimal is 6.9999. So root 48 is less than 6.9. This is 6.99, whereas root 48 is 6.92, which is less than. Replace the dot with a less than, greater than, or equal to. 12 and 169. Root 169 is 13. 12 is less than 13. Root 75 and 8.6. Root 75 is 8.660. 8.6 with that line over it means that it continues as a 6, So we know that 8.660 is less than 8.6666. Less than. Write 12 over 5, root 6, 2.4, and 61 over 25 in order from least to greatest. Write each number as a decimal. First, you're going to make all of these into decimals so you can compare them. 12 over 5 is 2.4, terminating. Root 6 is about 2.4495. 2.4 with the line over it means it's a repeating number, 2.444. 61 over 25 is 2.44. 2.4 is the greatest number. 2.40 is greater than 2.44, which is greater than, 2.4 is the smallest of these. 2.4 is less than 2.44, which is less than 2.444, which is less than 2.4495. This is the least, and this is the greatest. The numbers arranged in order from least to greatest would be 12 over 5, 61 over 25, 2.4, and root 6. Write 5 over 2, root 5, 2.2, and 51 over 20 in order from least to greatest. First, we're going to make all of them into decimals. 5 divided by 2 is 2.5. Root 5 is 2.236. 2.2 with that repeating sign is 2.222. And 51 divided by 20 is 2.55. So in order, the smallest is right here, 2.222. 2.2 repeating. The next smallest is root 5, 2.236, slightly larger. The next would be 2.5, 5 over 2. And the largest number is 51 over 20, 2.55. Multiple choice test item. For what value of x is root x less than 1 and 1 less than 1 over root x? True. A, -5, B, 0, C, 1 over 5, D, 5. Read the test item. The expression root x is less than 1, 1 is less than 1 over root x is an open sentence, and the set of choices are -5, 0, 1 over 5, 5 as the replacement set. The numbers listed here. First, solve the test item. Replace x in root x in the equation with each given value. So for A, replace it with -5. Is root of -5 less than 1? And is 1 less than the 1 over the root of -5? No, false. They're not real numbers. Root -5 is not a real number. If you are to do root -5 in your calculator, it would not give you an answer. It would say error. You cannot have a root of a negative number. So you know that A cannot be correct. B, plug in 0. Root 0 is less than 1, and 1 is less than 1 over root of 0. You cannot have 1 over the root of 0. The root of 0 is 0, so you would have 1 over 0. You can never have a fraction with 0 on the bottom, so you know that B cannot be true. Now, plug in root 1 over 5 is less than 1, and is 1 less than the 1 over root of 5. But we have 0.4472, that's less than 1, and 1 is less than 2.236. So we know it's true. C is an option, it is true. But we're going to check D just in case. Is the root of 5 less than 1 and 1 less than the root of 5? No, the root of 5 is 2.236, that's not less than 1, and 1 is not less than 0.44. 1 is greater than that. So we know that D is also false. The answer does not make sense. So the answer is C. The only option that worked in that equation is C. For what value of x is root x greater than 1 over root x? Well, we immediately see that C cannot be the answer because we know that no fraction can have 0 as the base. 1 over root of 0. We also know that you cannot have a square root of a negative number. So we know that the root of negative 3 will not be the answer. So we either have A, 3, or D, 1 over 3. So plug them in and see which is correct. The root of 3 is 1.73. Is that greater than 1 over 1.73? Well, 1 divided by the root of 173 is 0.58. Is 1.73 greater than 0.58? Yes. So we know that A is true. We're going to check D just in case. The root of 1 divided by 3 is 0.577. Is that greater than 1 over the root of, greater than 1 over 0.577? Well, 1 divided by that is 1.73. Is 0.577 greater than 1.73? No, it is less than. So we know D is not true. The answer is A. End of lesson 2-7.